In this video, we're going to talk about quasi-option value. So here is the setup of the problem. In time period 0, you can either choose to wait or to invest. If you invest, then you get a probability Q of receiving a high return of RH in T1. Okay, not in this period, but next period. Implicitly, you have a probability of 1 minus Q to receive a low return, which is RL, also in T1. And you will receive a R0 in this period when you invest. So the investment return is generated at the same period. Or you can choose to wait, and your current payment is 0, but you get to see the next period. Okay, what you will see in the next period is whether or not you will get a high return or low return for sure. Okay, so the Q is either 1 or 0. After that, you will decide whether or not you want to invest or not. Okay, implicitly we are assuming that you would want to invest if RH is high, but you don't want to invest if return is low. Okay, so now let's draw a diagram. At T0, you can either choose to wait or you can choose to invest. Okay, at T1, you will observe the state of the world, and you can choose either to invest or not invest. Okay, if you not invest, the payment is easy, which is 0. Now we need to figure out what is the net present value of these two options. And before we go into the mathematical details, the intuition of a quasi-option value is basically saying that how much you are willing to pay to wait for one period. So to delay your decision from here to here. Okay, so give you the decision, or in another way, so waiting until the second period gave you the option to choose not invest. Okay, and how much you would like to pay for that privilege. That's intuition. Now we are going to do some number crunching. Let's starting with the easy part. Let's first attack this number. Okay, in that case, we know that we will receive RH at that period, and we will receive RH over R for all the rest of for eternity. That's easy. Okay, and we will pay a cost of K for the project. But that is the present value of T1. We need to get them into T0, so we will multiply by discount factor 1 plus R, and if you do the math, you will realize that the value is this. Okay, so let's write it out. It is RH over R minus K times 1 plus R, which is net present value at T0. Okay, but that is not all of the story, because the net present of waiting actually involves option of invest and not invest. Okay, so if not invest, the present value is 0 because we are not going to do anything. So the expected value of waiting actually works out to be Q times RH over R plus K minus K 1 plus R plus 1 minus Q times 0, and that works out to be 0. So now what about we actually invest in the first period? So we know that we'll get R0 for sure, and then we know we're going to pay K for sure, and for the benefits from T1, there's a Q probability that we'll get RH forever, which is good, but a 1 minus Q probability that we'll get RL forever, which sucks. And that is the present value at T1, and then we need to translate that into T0, so we need to times the discount factor here, and that is our EI. And so now we get the quasi option value is just EW minus EI0. Let's have a subscript 0 here. And by some calculation that you get the option value to wait to the next period is actually this expression. Okay, it's quite messy, so now let's try to somehow make sense of it. And since we are kind of like economists, the way we make sense of things is taking partial derivative. Okay, now let's say this is our quasi option value. So QOV over partial K is equal to 1 minus Q 1 plus R. So can we sign this expression? Yes, we can, because we know that 1 plus R is larger than 1. So so discount factor is actually smaller than 1. And we know Q is bounded between 0 and 1. So the whole thing here is definitely smaller than 1. And 1 minus a smaller than 1 stuff is larger than 0. So that means, in some sense, the more costly the project is, it is better for us to wait until the next period. Okay, so now let's look at the other two. Let's see, QOV partial R0, obviously negative 1, which is smaller than 0. That means, okay, the larger the price for investment today, the lower the value of waiting for tomorrow. Okay, so now let's look at the RL. So QOV partial RL is equal to what? Negative 1 minus Q over R, which is smaller than 0. That means the lower the RL, the less valuable the future. So that means the higher of the value of the low return, the less valuable it is to wait, which is also reasonable. That if you think extreme case where RH and RL is the same, then there's no point of waiting anyway. Okay, so you will be noticed that there's no, in this expression, okay, there is no RH. Okay, this is not a coincidence. Well, at least in the setup, it is buried in the setup, because you will get if you decide to invest, okay, you will get RH no matter what. And actually, the probability that you will invest is exactly the same. Okay, the option value only comes from the option that you can choose not to invest in the bad state. That is essentially where the option value is coming from. All right, enough of that. Last point, let's do Q, which will give you negative K1 plus R plus RL over R. So here we will claim that this value is smaller than 0. Why? Because this is exactly the expected net present value of investing RL, and we assume here that this one is smaller than 0. That's why we will not invest. Okay, that means the higher probability of the high return, the less value it is to wait. Again, you can think about extreme case where Q is equals to 1. There's no point of waiting anyway. And if you would like to think more carefully, that means basically because the option value only comes from avoiding the low return state, and if the low return state is a very unlikely event, there's less value to waiting. Okay, so that is in simple example of quasi option value. Thank you.